All right, hi everyone. We are looking at the first day of our semester of one review, so fall semester review. So we're going to be looking at roughly just a chapter a day because some of these chapters were actually put together into one unit. So we're going to do basically a chapter a day. We're going to start all the way back at the beginning with chapter 1, which was our basic tools of geometry, those basic undefined terms and those postulates that we looked at. So we're going to start off again, just reviewing a little bit about how did we name some of these objects. So remember, a point was specifically a dot. And remember that dot had no size or shape with it. All right, it could be a huge giant dot that's easily to see, or it may not have a big giant dot at all. All right, but either way, if we are looking for some kind of dot, either teeny tiny or giant sized, and remember, we name it with a capital letter. So even if there is not physically a dot, you don't see it, but there is a capital letter there, then it is still referring to a point. So if I have, let's say, a giant dot with a capital letter A next to it, again, this would be point A. Or I could have a teeny tiny little dot with a B, and you still have point B. Okay, so size does not matter at all for these dots. The next one that we talked about, the big one here, was line. Line was made up of 2 points. There we go. Make the dots a little bit bigger. Okay, so let's say we have A and B. So to name this with the symbol, it had the line symbol and the 2 dots. Order does not matter. So we could have also called this line BA. Okay, that was the same idea. Also with a line, we had the lowercase cursive letters out at one of the arrows. So this would be line L. Okay, that would be line L. Now, line was also into 2 other kinds of pieces here when we didn't talk about the whole entire line. We had the segment, which was made up of just a piece of a line with a beginning and an end. So this was segment, let's say XY. Or you can reverse the letters, Y, X. So remember, with a line and a segment, it can be reversed because you've got the same kind of thing happening at each end, whether it's an arrow at each end or a end point, a dot, a single dot at each end. It could go either way. The other option we had when it came to lines was the ray. Now, ray is very specific because you have to start off with whatever letter is at the end point, and whatever letter might be at the arrow comes next. So ray MN, and that's it. No other options there for that one. So those are all our different variations of the line that we looked at. Then we had the plane. Oh, and before I forget, oops, no, we'll look at that in a second. Okay, so sorry, back to the plane. All right, remember, a plane is considered a flat surface. It's the best way really to describe this to remember. So like the walls or the ceiling or the floor in your home, or you could have your desktop, a sheet of paper, any kind of flat surface could be considered a plane. Usually, though, it's drawn as a 4-sided enclosed figure, but it doesn't always have to have 4 sides. Remember, we need 3 dots that do not line up. They have to be non-collinear to be able to name this plane. So let's say we have P, Q, and R. So we can call this plane R. I'm sorry, plane PQR. We only need 3. There might be more dots on there, but again, minimum 3 as long as they don't line up. The other option we have, remember, this had the capital cursive letter in one of those corners. So notice now there's no dots. That is a capital cursive. So then we can also call this plane K, and it's still capital and cursive, that K. All right, so again, if there is not a dot anywhere near a letter on a plane, then that is a name for that plane. It is not a point. So just be very careful with that. There were some postulates that we needed to remember here to make up a line and a plane specifically. And that is the fact that there is exactly one line through any 2 points, and there is exactly one plane through any 3 non-collinear points. Remember, non-collinear means they don't line up. Collinear by itself, collinear, they do line up. I can connect them all with one straight line. All right. Now, when we talked about your lines, we were able to go into our next little section, which was on distance and midpoint. So you have your distance formula, which was the big square root. And remember, for distance, we're also, it may not come out and say exactly find the distance, but we can look for other phrases. How far? Length. Those all those phrases mean we are looking for the distance from the first point to the second point. So with that big square root, let's practice it real quick. Find the distance between these 2 points. Remember, we have to make sure we know which point is x1 and y1, which point is x2 and y2. Once we know the labeling, then we plug those values into the big square root formula. Oops, sorry, it's moving on me. So our distance is, let's get our big square root up here. So inside, so I'm going to make this just a little bit bigger. Inside our square root, remember we have 2 sets of parentheses, both with a subtract. And then we have to add those 2 groups together. So now let's plug in our values. So remember, we need x1 first, which is a -2. And then we need x2 last. Oops, sorry, I think it's x2 first. Yep, sorry, they want x2 first. So we need x2 first, which is 2, minus x1 and -2. And then we're going to do the same thing to the y's. y2 first, which is +2. y1 is a -1. And let's see what we get. All right, so my distance equals the square root of, now remember, 2 minus negative is the same as a plus. So in our first set of parentheses, we really have 2 plus 2, which is a 4. And then we will square that and do the same thing to the second group, and then we'll add them together. So again, 2 minus -1 is the same thing as an addition, a plus. So 2 plus 1 is 3, and we're going to square it. So let's keep going. Let's see what we get. All right, so now we have 4 squared, which is 16. 3 squared, which is 9. Add those together, which gives us the square root of 25. So my final distance between those 2 points is 5 units. Okay, that was our final distance. Now, another way that we can find distance if they don't necessarily give you the 2 points is the Pythagorean theorem. And I'm just going to remind everybody of that formula. I'm not going to work through this one. Pythagorean theorem was another option we saw, which was a squared plus b squared is equal to c squared. We drew out the right triangle, and then we counted units to make the a and the b in order to find out your c. So just that was another way that we found for that one. So I will draw just a quick little example here. We had a grid. You had 2 points. I'm not going to do quite such a big grid here, just in quadrant 1 maybe. And you had 2 points. And you had to find the distance of that. So remember, Pythagorean theorem said draw the right triangle. One side is A, one side is B, and your hypotenuse is the C side. And that was another way that you could find the distance. So you had those two options. Now, another formula that we looked at when dealing with segments was your midpoint formula. And again, to find the midpoint of 2 points on a graph, this was to add up the x's, divide by 2, add the y's, divide by 2. So let's see, our midpoint. Again, we're going to add up those x's and divide by 2, add up the y's and divide by 2. So similar situation to the last one. We've got x1 and y1, x2 and y2. And we're going to start with x2, which is that same 2, plus x1, negative 2. And then we do the same thing to the y's, y2 plus y1, 3 plus negative 1. Let's see what we get. Let's add those together. All right, so 2 plus negative 2 leaves us with a 0. And then we'll divide that by 2. And then we're going to do the same thing to the y's. Whoops, sorry, my iPad crashed on me for a second. Okay, sorry about that. All right, and then we'll do draw. All right, and then we'll do the y's, add up your 2 y's. So 3 plus negative 1 is a positive 2. And then let's just simplify this and see what we get. All right, so 0 divided by 2 is a 0. 2 divided by 2 is a 1. So there is my midpoint. That is the point in the middle of the two ends when we're looking on a graph. All right, so that was kind of our first part there when dealing specifically with segments. Once we were done with segments, we moved into angles. What happens when we start putting some lines together or possibly just rays together, and we created angles, and then we looked at their different relationships. All right, let's start with angle. All right, we talked about angles were made up of 2 rays that have the same end. Okay, angles were named in 2 different ways. So let's get some letters up here. So let's say L, M, and N. All right, so one of those ways was with 1 letter, and we could call this angle and whatever is at the vertex. Okay, what the angle symbol and whatever is at the vertex. But when it is not just 2 rays, maybe there's more than 1 ray coming off of that 1 point, we're going to see this way a whole lot more, and that's with 3 letters. So remember, with 3 letters, you still have your angle symbol, but you start at the arrow. So let's say if we start at L, then I follow back to M, and then I follow it out to the other arrow, N. Or we can reverse that. I'm actually going to do this one a different color. We can reverse it and start at the other arrow, N, follow it back to M, and then back out to L. And those were our 3 different ways that you can name. And again, you will see the one with way 2 there with 3 letters a lot more than you'll see with just 1 letter. So again, you have to remember that those letters are telling you the order to follow. They're basically tracing out the specific angle they want you to look at. And it's also kind of think about it like a corner, right? Those 3 letters are telling you what specific corner space that you need to look at. Now, once we'd had angles, we talked about what made up some specific angle pairs. We had adjacent angles. which was just two angles that share a side. So right now, these two angles are sharing this ray. So these two spaces are adjacent. They are neighbors. Oops, sorry, I can't spell. They must share a side. All right. Then we had vertical angles. Vertical angles happened when two lines cross. Let's get some angle spaces in here. All right, so remember your vertical angles were across from each other, so angle 1 and angle 3. They are across. So angles 1 and angle 3. The other option could be angle 4 and angle 2. And the big thing here to remember is that they are congruent. So if angle 2, let's say, is 100, so is angle 4. If angles 1 is 80, so is angle 3. They are congruent to each other. All right, from vertical, oops, we had another kind of angle pair, which was a linear pair. So similar picture. But this time, linear pairs, let's get some numbers up here again. Linear pairs are adjacent. Okay, linear pairs have to be adjacent. So I could say angles 1 and angle 2 could work. I could keep working my way around. Angles 2 and 3. Angles 3 and angle 4. And then our last pair, 4 and 1. And these are not going to be congruent. These are supplementary. These are supplementary, meaning they must make up 180. And we'll revisit supplementary here in just a second, a little bit more. All right, complementary angles. These angles have a sum of 90 degrees. So whether that is two angles that are sitting inside a right angle, so angle 1 and angle 2, or it could be just two separate angles that don't touch each other. When those get added together, we get 90 degrees again. So again, sum of 90 is complementary. And then we have supplementary again, which, like we found earlier, was a sum of 180. So again, that could be two angles that are a part of a straight line. So let's say 80 degrees and 100 degrees together, they make up 180. Or we could have two angles that are not adjacent. So 90 degrees, oops, sorry, wrong color. 90 degrees plus 90 degrees, 180 degrees. Now keep in mind with complementary and supplementary, the two numbers do not have to be the same when you are adding them together. Just remember that. This is just an example. All right. A couple other vocab terms that we looked at, especially when dealing with angles, is the idea of a bisected angle and congruent angles. So remember, bisect means to cut in half. I'm going to zoom in here. So whether we are cutting an angle in half or cutting a segment in half, anytime you see bisect or any variation like bisected, bisector, they always mean we're cutting something in half. So if I'm cutting an angle in half, so a bisected angle is an angle cut in to two equal parts. And we talked about how do we identify those two equal parts, and that's where the next part down, congruent angles, comes in. So let's say I have an angle that is being bisected. So then on either side of that ray, we get those congruent curves, which mean equal. Okay, so those matching curves are what we're looking for congruence. So those two pieces, those two skinny pieces there, are in fact equal because of those congruent curves. That ray in the middle is bisecting that angle. So let's practice some of this with some algebra here. Again, anytime you're dealing with angles, you have to see what kind of relationship do they have. Are they across from each other? Are they next to each other? Are they neighbors? Should they be congruent, or should we add them up to equal 180? And it's all about where are they sitting. So for this specific pair, these two angles are sitting directly across from each other. Remember we talked about how if they're on an X shape and they're across, that's where we're looking at the congruent. These are vertical, which means they are congruent to each other. So 3x minus 40 equals 2x minus 10. And we are just solving this for x. So let's solve this out then. Minus that 2x to both sides. So x, oops, sorry, wrong color. So x minus 40 is equal to negative 10. Let's add that 40 back. And x is equal to 30. All right, number 2. Straight across. This time, our two angles are next to each other. Which means they are adjacent, so they should add up to 180. These are linear pairs. So that means this time we will add them together. So 6y minus 10 plus, there's the first one, and then we'll add the second one, 6y plus 10 equals 180. And now we can combine like terms. So 6y and 6y gives us 12y's. And then we'll do our plain numbers here. So we've got a minus 10 and a plus 10. Minus 10 and plus 10, they actually will cancel out. So 12y is equal to 180. Now we can divide out the 12 because there are no plain numbers here to add or subtract back. And my missing y is 15. All right, now let's go and check out example 3. All right, so first thing I notice is I have a 90-degree box on one side of that line. One of the specific things I talked about a lot in the other videos, and especially in class, if one side of the line has 90, so does the other side. So these two angles together are complementary because they're both making 90. So they together have to add up and be 90 degrees. So 4z minus 10 plus another z make 90. Let's solve this now. Combine your like terms because we've got 4z and another z. So 5z minus 10 is 90. So we can now add that 10 back. Five z is equal to 100. One more step, divide by 5. And z is 20. All right, let's do our last one here. We've got two variables in this one, and that's fine. Again, it's all about what kind of relationship do we have. All right, so it doesn't matter if you want to start with x or y here, but one thing I know is 7x and the space where 98 are, those are vertical again. So they are going to be congruent. So let's get that one first. So 98 is congruent to 7x. So we can divide both sides by that 7, which gives us a 14 for x. Okay, those two are vertical. Now we can get your y. Because 98 and 5y minus 3 are linear pairs. So 98 plus 5y minus 3 have to make 180. Okay, and again, let's combine our like terms here because we've got 98 and a minus 3. There's no other y's, so we have 5y. 98 minus 3 is a positive 95. Equals 180, and now we can start our solve. So we're going to have to minus that 95 to both sides. So minus 95. All right, I'm going to come over here. So 5y is equal to 85. One last step. Now we can divide both sides by that 5. And my y is 17. All right, guys, I hope you enjoyed learning a little bit about our chapter 1, just our basic terms here, and reviewing all of this for our semester exams. Please don't hesitate to reach out to me if you have any questions at all. Bye, guys.